Most calculus classes will begin by looking at the definition and the concept of limits. And perhaps in your algebra classes, you have done limits, but the word limit hasn't been used. So let's look at the official definition of what a limit is, and then we're going to introduce limits graphically because sometimes it's a little bit easier to see it visually before you start to find limits algebraically. So the definition is if f of x, remember f of x is the y, so if f of x gets closer and closer to a number L, and L would be any real number, as x gets closer and closer to c, and c would also be any real number, from both sides, then L is the limit of f of x as x approaches c. This behavior is expressed by writing the limit, Lim, underneath it, x is approaching c, of the function f of x is equal to L. So the key word here that we're looking at is the word behavior. All right, so it's important to remember that when you're looking at a limit, you're looking at the behavior of what's happening with your function. And what's happening there is that you are given what x is doing. So you are told this is what x is approaching. So x is getting closer and closer to this number. And then you're going to answer what y is doing. So one more time, you are told what x, the behavior of x, and you want to answer, okay, when x is doing this, what is y doing? And that is going to be the limit. So when you answer a limit, an important thing to remember is that this answer is the y behavior. So let's take a look at, we're going to have two different graphs. The first one is going to be a very easy graph, which is a graph of a line. So we're going to graph f of x is equal to x minus 3, which is also y is equal to x minus 3, which means that it has a y-intercept of negative 3, and it has a slope of 1. So up 1 over 1. And just in case, the reason I know that it has a slope of 1 is because the slope is the number in front of x, and the number in front of x is an assumed 1, a positive 1. So it has a positive slope. So up 1 over 1. And I'm just going to do a few points. When I graph, I like to use the entire graph. And then we are going to connect these points for a nice line that looks like this. Okay, so here's my graph, and of course you don't have to do so many points. I'm just really doing it for emphasis. So we want to discuss the behavior of the y-coordinate as the x-coordinate gets closer to 4. So let's first look at x is equal to 4. Let's go there. So that's right here. And what we're going to do is we're actually going to approach x going to 4 from both sides. So if you look at the real number line, right, if I just take the number line here and I put 4 right here, you can approach 4 from two sides. And the two sides that they're talking about is either you can come in from the left, which would be coming from numbers that are less than 4. So this would be from the left. Or you can approach 4 from the right. So numbers that are greater than 4. So that's what they're discussing in the definition when they're discussing from both sides. So if I take a look at my graph, you can imagine that it's like you're driving on the graph. Like you're driving your car and you're approaching an exit from two different directions, right? So if you're on a north-south highway, you can either approach an exit from the south direction or you can approach an exit from the north direction. So it's kind of like you're driving on the graph and you're approaching your exit. So if I'm coming in from the left of 4, I would be getting closer to 4 on this part of the graph. And if I'm approaching 4 from the right, I would be coming in from the top. So this is what I would look like. So I'm approaching from both sides, and then I want to look at what the y is doing. So what the y is doing is over here. This is what the y is approaching. And the y is approaching 1. So as my x is approaching 4, I'm getting closer and closer to y is equal to 1. Now, what's very important with limits is that you don't care, just to answer the limit part, you don't care what the y is, you care what it is approaching. And that's a word that you're going to hear a lot when you're talking about limits, okay? Because it's what you're approaching. It's not what the number is at x equals 4. And we'll see a little bit of a difference when we get to the next graph. But it's what the number is approaching. So as x is approaching 4, y is approaching 1. And then the really important part of this is actually the notation. So you have to use the limit notation, and there are 4 parts to the limit notation. The first part is the fact that you have to use the word lim to denote that you're taking a limit. Underneath the limit symbol is the behavior of what the x is doing. So in this situation, the x is approaching 4. Then it is your function. And this is the part where I've seen a lot of my students really struggle with, and it's putting something after the limit. You have to have something after the limit. It's the limit of a function. So in this situation, you actually have 2 options. You can either write f of x, or you can instead write the limit as x approaches 4, and because you know what the function is, you could actually write the function x minus 3 instead. We'll put it in parentheses. And that is equal to what your limit is. So what is your y approaching? And we found out visually that our y was approaching the number 1. A good rule of thumb that I say is that if you're writing an equal symbol directly after the lim, something's very wrong. All right, so it's the limit of something. You need 4 parts: the limit symbol, the lim, what goes underneath the limit, the function, and then equal to your limit. So there are 4 parts. So make sure that you always have those 4 parts. Otherwise, it does not make sense and it will be incorrect. So work on the notation, because like I've said, this is actually something that I see many of my students struggle with. So work on writing the notation properly. What you don't want to do is you cannot write the f of x and the x minus 3. So it's either you write the f of x, the name of the function, or you write what the actual function is if it's given to you. So let's take a look at a different function. We have a piecewise function here, a 2-piece. The first piece is x squared when x is less than 1, and the second piece is y equals 3 when x is greater than or equal to 1. So the pieces here on the domain, you have to look at where the pieces are being defined. So the first piece is when it's less than 1, and the second piece is when it's greater than or equal to 1. So that's going to happen, right? If we make a little symbol, it's going to happen right here. This is where it's changing. So the first one I'm going to do is, first I'm going to do y is equal to 3. It's a little bit easier to graph because it's just a horizontal line. So the piece starts when x is greater than or equal to 1, and because you have the equal to 1, you're going to do a closed circle. So you're going to have a closed circle at y equals 3, and then your piece is going to be defined everywhere where x is greater than 1. And then our second piece, y is equal to x squared, I should say it's our first piece, but we're graphing it second, is a parabola. And then this one is strictly less than 1, so you're going to have to use an open circle. So when x is 1, 1 squared is 1, so it's going to be 1, 1, open circle. And then we'll do a few other points. So when x is 0, y is 0, and say negative 2, 4. And then remember that a parabola is not a line, right? It needs to be curved. And here's our graph. So we're going to look at 3 limits. So the first limit is when x approaches 3. So I'm going to try to color coordinate a little bit. So x is equal to 3 is here. So I'm going to go up to my graph, which is the horizontal line at x equals 3. And I'm going to look at what happens when I'm approaching it from the left and what happens when I'm approaching it from the right. And in both directions, from the left and from the right, I look at my y, and my y is approaching 3. So the limit as x approaches 3 of f of x is also 3. Now let's do negative 2. So let's circle negative 2. It's right here. Just doing it for emphasis. You don't have to do that. So as I'm approaching from the left, I'm coming down. And as I'm approaching from the right, I'm coming up. And as my x's are getting closer and closer to -2, my y's are getting closer and closer to 4. So the limit as x approaches -2 of f of x is equal to 4. Again, look at the notation. Very important. 4 parts here. I got my limit, I got what my x's are doing, I got my function f of x, and I got what it's equal to. Now we have one more limit. The limit as x approaches 1. So I'm going to go to x equals 1. And as I'm approaching from the left, I'm actually on the parabola here. So I'm approaching from the left, I'm on the parabola. But as I'm approaching from the right, I'm on the horizontal line. So I'm on two different pieces for x equals 1. So as I'm approaching from the left, my y's are approaching 1. But as I'm approaching from the right, my y's are approaching 3. So I'm approaching two different numbers. And so when that happens, and we're going to learn a lot more about this in the next video. So if from the left, you're approaching a different number than from the right, the limit actually does not exist. Because I'm approaching two different numbers, and you can't have a limit being two different numbers. They have to be one answer. And for short, very luckily for us, we actually can write DNE, which makes it a little bit faster. So like I mentioned, we're going to learn a lot more about that, about the limits approaching from two different sides in the next video. But here we have a little bit of an example to kind of introduce it.